Okay, so this is lesson one. Just some introductory star facts and some stuff on the sizes. Remember the star sizes, we have anything from these tiny white dwarfs up to, medium-sized stars, kind of like our sun. We get to large stars, and then we get supergiant stars. Stars can have all different sizes. Well, how do these stars form? Well, they form when a cloud of dust and gas, called a nebula, collapses into a ball of hydrogen, and that is caused by gravity. So that's basically what starts it. Here's a drawing. So we have a nebula, which is a big old cloud of dust and gas. That dust and gas starts maybe clumping up. Maybe there's a big clump of it, and as that clump has its own gravity and attracts more and more, what you end up with is inside of a nebula. So here's remaining gases in the nebula. Inside of there, gravity starts pulling more and more of that dust and gas into a star. And as that star gets bigger and bigger, it has more gravity to pull more and more dust and gas into it. Now, as soon as that star starts shining brighter and brighter, because it's getting more and more massive, then it starts shining and blowing all that extra dust. The final dust gets blown kind of away out of the solar system. That's how stars form. You start with a nebula, gravity makes it lump, and it starts falling in and in and in until you have enough mass for something called fusion to happen. So fusion. What is fusion? Fission is when you take two hydrogen atoms and slam them together to get lots of energy by creating helium. But in short, the intense heat and pressure from all of the weight cause the hydrogen to slam together and form helium. And in forming helium like this, it's releasing just a ton of energy. So inside of a star, when two hydrogen atoms are moving so fast, they slam together, they end up joining into helium. Hydrogen has one proton plus one proton equals two protons, or helium. Okay, so if you have a hydrogen, which only has one proton, that happens to slam into another hydrogen, which happens to have one proton, and they have enough energy that they don't repel each other like they want to. But if they slam together, they end up making helium and releasing just a ton of energy at the same time. That's what a fusion reaction is basically hydrogens coming together and creating helium and releasing just an absolute ton of energy. So lastly, now these stars right here have different colors. And as you look up into the night sky, you'll see that there are different colors to stars. What is up with that? So stars, if you look up in the sky, you'll notice they have different colors. And that color depends on its temperature. Stars can have different temperature depending on their size, what they're made of, all sorts of stuff. But in short, to keep it simple, let's make a T-chart with the temperature and the color. So we're going to have cooler stars at the beginning. We're going to work up to hot stars. The color of the cooler stars. Now the coolest stars end up being red. Red is the same color your oven burners turn when they first start warming up. If you could make an oven burner turn hotter and hotter and hotter, it would go from red to white. Because it would be giving off red at first, just red, and infrared, and eventually it'd be giving off all the wavelengths. Well, anyway, a slightly hotter star is going to be orange, sort of like our sun. Okay, you get to white-orange as they get hotter yet. But the hottest stars are the blue stars. Blue is the hottest type of star there is. There are things in the universe, however, that are so hot we can't even see them. They're not even giving off blue light. They're giving off X-ray light. mostly.